Hello everyone, so welcome back to my YouTube channel Kasiligan Vlogs, and today we will be talking about continuous random variable application to problem solving. So let us start with problem number 1. So we have here the weight of fish in kilogram in trout farm is given by probability distribution function f of x over 50, the interval from 0 to 1 over 10, and 0 elsewhere. So first is we need to calculate the maximum weight of the fish. So since if we're going to look at here, the maximum weight is this one from x is greater than 0 and x is lesser than or equal to 10. So therefore the maximum weight in this case is equal to 10 kilogram. So the maximum weight is given by the domain of the function. So what is the domain of the function? F of x, the maximum weight is given by x 10 kilogram. So next one is the expected weight of the fish. So let's have letter B. So the expected is equal to mu, or expected is equal to from A to B x f of x dx. So here from 0 to 10, x times what is our fx, x over 50 dx. So from 0 to 10, our mu here, we have x squared over 50 dx. So we have to integrate now the mu, x cubed over 150, because we are going to multiply from 0 to 10. So our mu here is x cubed over 150 from 0 to 10. So our mu here is 10 cubed over 150 minus 0. So our mu is equal to 1000 over 150 minus 0. Our mu is 20 over t. So this is problem number 2, or question number 2. Next is that is the expected of the weight of the fish. Next is the probability that a fish weight less than 4 kg. So if we're going to illustrate this, okay, like this, we're going to illustrate. So and we're going to substitute the value for our 10 here. So that's equal to 1 over 5. Assuming this is the point here is 10 and 1 over 5. And we need to get the probability that fish weight less than 4 kilograms. So this one less than 4 kilograms. So PR x is less than 4. Or it could be the interval from x is greater than 0 but less than 4. Or it could be like this. So if we're going to use our geometry, so area is equal to b, since we are dealing with triangle, base times height over 2. So now our base here, since we need to get the less than 4, our base is equal to base of the triangle is 4. Next, we have to find the height. The height of a triangle is f of x. So x, because this is the height of the triangle, that's the change of this one, the function, that is x over 50. That is since we are going to substitute the value for x is 450, so the height is 2 over 25. So by the use of the area is equal to base times height over 2, what is the base? 4 times 2 over 25 over 2, that is equal to 4 over 25. So that's the area which is lesser than 4. Or you could have, you could solve using this one. So P from probability from x is greater than and lesser than 4 from 0 to 4, and the function is x over 50 dx. So we could integrate this. This would become x squared over, we have 50 times 100 from 0 to 4. So we have here 4 squared over 100. So 4 squared, that is equal to 16 over 100. That's equal to 4 over 25. So that's the concept when you're going to use this geometry and by the use of the integration formula or the integration process. So that's it for question number letter C, which is the probability that a fish weighs less than 4 kilograms. So the next one is the probability that a fish weighs more than 8 kilograms. So let us letter D. So if we're going to show that one in illustration, so here 10 and 1/5. So let us assume that is 10 and 1/5, and going 8 to 10. So what is the question here is, what is the probability that the fish weight more than 8 kilograms? So this more than 8 kilograms. So PR is greater than 8. So from here, starting with 8, going to 10. X is greater than 8 but lesser than 10. Here, so we have integral from 8 to 10, x over 50 dx. So this will become x squared over 100 from 8 to 10. So this is 10 squared over 100 minus 8 squared over 100. So 100 over 100 minus 64 over 100. So this should become 100 minus 64, 36 over 100. So 36 over 100, that is 9 over 25. So P x is greater than 8. So that is the probability that a fish weighs more than 8 kilograms is 9 over 25. So let's proceed now with problem number 2. The length of time between the successive incoming calls to a certain national helpline is continuous random variable with the probability density function given by this one. and find the correct 4 decimal places. The probability that the next call will be first within 30 seconds of the previous call, B is between 2 to 3 minutes after the previous call, and more than 7 minutes after last call. So this is in minutes, so we could have this one as 0.5 minutes. Okay. The first thing that we're going to do is we need to find within 30 seconds of the previous call. So starting with the probability, starting with x from 0 to 0.5. Okay, within 30 seconds of the previous call. So they're going to say that is close interval from 0 to 0.5. So that's integral of 0 to 0.5, 0.6 e raised to negative 0.6x, and dx. So this is all about exponential function. So if we're going to illustrate this, so this is the illustration. So okay, it looks like this. Okay. Okay, from 0, 0 to 0.6, since we're looking for within 30 seconds calls here, within 30 seconds calls, from 0 so to zero point 0.5. So if we're going to integrate this one, so let u is equal to negative 0.6x, our du dx is equal to negative 0.6. So neutralizing factor, which is negative uh, negative 1 over 0.6. So from this part, so we need now to integrate. So starting, we have 0.6 e raised to negative 0.6x divided by this to the count, or could have 1 over negative 0.6. So negative 0.6, because we have to multiply it immediately because this is our neutralizing factor from 0 to 0.5. So just multiply here. So substitute the value 0.6 e raised to negative 0.6 times 0.5 over negative 0.6. So cancel this 0.6. This will become negative e raised to negative 0.6 times 0.5 minus e raised to negative 0.6 times 0. Okay. So e raised to alpha e negative 0.6 times 0.5. That is the result of this one is negative 0.7408. Since this is a 4 decimal places, minus this is e raised to 0. So e raised to 0 is equal to 1. So we have here negative 0.7408. This is negative. So to change the sign, this is become plus. So plus 1. So minus 1, that is 0.2592. So this is how to solve for letter A. But for cumulative functions for exponential distribution, so we have to take note of this one. That we could solve that using p x is lesser than x is equal to 1 minus e raised to lambda x. Okay, so that's lambda x. So we have in this example, so we could have this one as probability of x is lesser than 0.5. That is 1 minus e raised to negative 0.6 times 0.5. So that is 1 minus e raised to negative 0.3 equals to 1 minus 0.7408, that is equal to 0.592. So we have to take note that this is for an exponential distribution. This is the cumulative distribution function. Okay, that's it. This is the options or the other way around in solving the problem. Next is between 2 and 3 minutes of the previous call. So 2 and 3 minutes of the previous call. So this is letter B. So 2. So PR. Okay. Is equal to 2 to 3, 0.6 e raised to negative 0.6 dx. So this will become from integral. Okay, this will become 0.6 e raised to negative 0.6 x over negative 0.6 from 2 to 3. That's based on the previous. So cancel. This is e raised to negative 0.6x over this negative over 1, 2 to 3. So this is negative e raised to negative 0.6x 2 to 3. So we have to substitute the value. So negative e raised to negative 0.6 times 3 minus negative e raised to negative 0.6 times 2. So e raised to negative, that it is 0.6 and 3, that is equal to negative 1.8 negative plus e raised to negative 1.2. So just change the sign of the subtrahend. So alpha negative, alpha negative, no, negative 1.8, that is equal to, this is negative, so negative 0.1653 plus e raised to negative 1.2, that is 0.301112 equals 0.1359. So this is between 2 to 3 minutes after the previous call. So we could have this one as probability. If that is an exponential function, so from x a to b, so this is for exponential function, we could have x is lesser than b minus p, x is lesser than a. So we have two formulas here. P is equal to 1 minus e raised to negative from p x 2 to 3. So this is negative 0.6 times 3 and minus 1 minus e raised to negative 0.6 times 2. 1 minus e raised to negative 1.8, then minus 1 minus e raised to negative 1.2. So 1 minus alpha negative 1.8, that is equal to okay, so this is equal to 0.8347 minus 1.2 0.6988. So 0.8347 minus 0.6988 is equal to 0.1359. So this is how to solve using exponential functions in this case. Next, we have the last number, or the last is more than 7 minutes. Okay, for more than 7 minutes, so P R is x is greater than 7 or equal to 1 minus P R x is lesser than or equal to 7. So that's equal to 1 minus 0 to 7, 0.6 e raised to negative 0.6x dx. 1 minus, we have to integrate now. So this is 0.6 e raised to negative 0.6x over negative 0.6 dx. Ano? From 0 to 7. 1 minus, this is cancelled. This is negative e raised to negative 0.6 x 0 to 7. So we have to simplify now. Okay, 1 minus, okay, e raised negative e raised to 0.6 times 7 minus, okay, minus 0. Negative e raised negative 0.6 times 0. Okay, simplify 1 minus, this will become negative e 4.2 plus e raised to 0. Just change the sign here, it will become e raised to 0. So simplify further. So we have here 1 minus negative e, that is 4.2, that is negative 0.0150 plus 1. So simplify, we have 0.0150. Or we could have this one as p when p is greater than, okay, when p is greater than the cos, we could solve using p x is greater than 7 is equal to 1 minus p x is lesser than or equal to 7. That's it here. So therefore, we could have that 1 as immediately as e raised to negative 0.6 times 7 is equal to e raised to negative 4.2, or approximately this is 0.0150. So that is 1 minus the probability of lesser than or equal to 7 is equal to e raised to 4.2. So negative alpha negative 4.2, that is 0.049 or 50. So that is next comes more than 7 minutes after the call. So we can have this one or either of that two is correct. So it's up to you on how to solve this one or how you're going to show the problem. It's up to your convenience. So if that is this case, or that would be the same case with here, we could have this, or we could have this one. Alright, so why is it that e raised to negative 0.6? Because 1 minus, this is 1 minus e raised to negative lambda x. So this will become 1 minus 1. And this is become positive. So therefore e raised to negative lambda x. So therefore we could immediately substitute e raised to negative 0.6 times 7, because 1 minus minus. There are two ways here. So thank you for listening, and try this at home. The time and hours of Catherine spends watching television each day is continuous random variable density function given by this function. So thank you so much for listening, and I hope everyone, you have to submit this. Try this during our class.